So there are many benefits of being endowed the ABS chair. It's a great honor, obviously, but it also allows me to relate to and communicate to the industry through ABS and their experience with the shipping industry. And so that helps me formulate my research question in a way to be more in line with the challenges facing the shipping industry at the moment. So my research involves a couple of interesting related problems motivated by soft robotics and deformable structures in a fluid environment. So I'm working on how to design actuatable structures so that they optimize their performance, such as speed or efficiency. And one of the motivations is biologically inspired swimmers, such as robotic fish that might be used for ocean monitoring or inspection of engineering structures. Biologically inspired engineering means that we try to design engineering structures inspired by natural solutions to come up with solutions that can help us out in some of the more complex tasks that face us. So I think the potential of soft robotics and in general deformable structures in the shipping industry and also the offshore industry is to provide eventually, hopefully, more efficient solutions to basic questions such as propulsion and maneuvering. So, one extreme component of this would be to come up with an alternative to the standard propeller by using a bio-inspired, for instance, a fish tail. Now, it's unclear right now if that is going to be a viable solution eventually, but to get there, we need to investigate the possibilities and the potential of using such a propulsor, maybe first in smaller scale systems, maybe first for fins and foils and appendages, and then eventually moving to larger structures such as an entire propulsion system for a large scale vessel. So 4D printing is a relatively recent technology, which is essentially 3D printing a structure and then changing the environment so that the structure changes its shape according to a desired target. And so it's also called shape-shifting structures. So 4D printing is going to be an important technology for soft robotics in the sense that it can help designing actuators that are maybe on a different scale than what's out there right now. So very complex shape transformations, very fast shape transformations. And so this can guide, again, the design of soft robotics to be much more flexible than what is possible now with traditional actuators. And this is not only soft robotics, this is also for just general engineering structures such as fins and foils and maybe even propellers down the road. So to have the opportunity to actuate a flexible structure in essentially an arbitrary way using an environmental stimulus. So we're trying to come up with a small prototype autonomous boat for use in the canals of Amsterdam in the Netherlands. With this project, we're trying to come up with algorithms and workflows to integrate the sensory data in an efficient way so that we can learn from that and design control algorithms that can be eventually also applied to large-scale vessels such as container ships or tankers that are crossing the ocean. I think a lot of the new technologies are combining innovations in different fields, from materials to just general mechanics to computer science with all the big data and autonomous, and then also there's an electrical engineering component with the sensors. New solutions are going to be integrating all those different components, and so it's important for both the naval architects and also the researcher side to be interdisciplinary, to have interdisciplinary skill sets and be aware of what's going on in other industries, how can we integrate those innovations in our industry. This is very important to have a set of rules in place, which is why the ABS guidance is an important addition to the industry.